Welcome to section 3.3. In this section, we're going to continue discussing random variables and specifically address what we mean and how we use the expected value of a random variable and the standard deviation of a random variable. This should remind you very much of the mean and standard deviation that we talked about with data distributions. It's basically the same thing, but translated to probability distributions. And there are some other ways we can perform the calculations that I'll let you decide if you think they're simpler or not. So let's start with a sample probability distribution. So let's say you play in a band and your band does gigs on the weekend. It's a side hustle. So you can perform up to 4 gigs at various local restaurants or at weddings or other events. So last year, you recorded for each week how many gigs you played that weekend. So you played 1 gig in the first weekend, 3 gigs in the second weekend, and so on. And you just kept track of it. Now this spreadsheet, as it's written, is not terribly useful. It's a very long string of numbers. What's more useful is to look at how many times we played each possible gig, number of gigs. So 6 of the weeks of the year, we played no gigs over the weekend. We got nothing. We got 1 gig, 14 weeks of the year, and so on and so forth. So now we want to turn this into a probability distribution. But to do that, we turn these frequencies into relative frequencies, noting that this is out of 52 weeks, and we convert those to decimals by dividing by 52, which we can certainly express as percentages if we like, by simply changing the format. And this is equivalent to a probability distribution. Right? So we took our raw data, turned it into a probability distribution, and we can make an assumption that this probability distribution will hold this year. So we expect the probability that we get no gigs to be 12%, 1 gig to be 27%, 2 gigs 15%, 3 gigs 21%, and 4 gigs 25%. And I made a little graph of this probability distribution for us. But here's the question. How many do we expect to get on average per weekend? That's expected value. We're given a probability distribution. We want to figure out how many on average we can expect to get. So we could just average up all the numbers from this column. That sounds a bit tedious. Instead, we can think about a weighted average where each of these numbers from 0 to 4 is the number and the percentages are the weights. Let me illustrate how that goes. So the expected value of a random variable is calculated by taking each observation, multiplying it by the probability of that outcome, and adding up all the results. That's what that equation means. Since the probabilities come from relative frequencies, you can think of pi as a fraction of the frequency with which something occurred divided by the total number of observations, and that would get you back to our original definition of average. We call this expected value mu, the Greek letter mu. So in this example, recall that we had no gigs with probability 12%. So we take the value 0, the outcome 0, or the observation 0, we should call it an outcome, this is probability, and multiply it by the probability of getting 0, which is 0.12. We do the same thing with 1 gig, multiply it by probability of 0.27, 2 gigs multiplied by its probability 0.15, 3 gigs multiplied by its probability 0.21, and 4 gigs multiplied by the probability 0.24, and now we're beyond capacity. Take those products, find them, add them all up, and you'll get the answer of 2.16. So on average, we can expect to have about 2.16 gigs per weekend over the coming of the next year based on our data from last year. You'll notice I didn't set this up in Excel. There's a reason for that. In the checkpoint assignment for this series of videos, I'm going to ask you to do that. You're going to figure out how to put this, calculate the expected value and the standard deviation in Excel. So be prepared. So in the next video, as I mentioned, we'll talk about standard deviation of a random variable, which is a measure of how spread out the random variable is, as it is with a data distribution.